In this video, we explore some commonly used observational designs, which are obviously very important in understanding research designs or the designs of research studies. So there are two main categories of observational designs: descriptive and analytical. Descriptive studies generally paint a picture of what is, while analytical studies really delve into why things are the way they are. So first of all, when we consider descriptive studies, we can think of them as snapshots in time that capture a moment or a series of moments. And they really are often used to provide a foundation for further exploration. First of all, when we look at the first type of descriptive study, they are case reports. And case reports are like single frames of a film, right? And they focus on specific incidents or a specific individual, and they usually are used to reveal unusual or rare occurrences that spark curiosity and that then leads to new research questions. For example, if you'd study one single historical person, that would be an example of a case report. Case series are collections of these single frames, and they provide a more comprehensive view of a particular phenomenon. For example, if you were to study, for example, multiple dictators, and then that can identify patterns. For example, what are their personalities like? How did they come to power, etc. And it can also reveal trends that might otherwise be overlooked. Finally, the last type of descriptive design is a survey. And surveys are, for example, questionnaires. And those questionnaires gather information from a large group of people. And as a result, they can provide valuable insights into the prevalence of certain conditions, certain attitudes, or certain behaviors. Now, mostly we wanted to talk about analytical designs, and analytical studies aim to understand the reason behind certain phenomena. And there are generally three groups, and we'll explore them here. There are cross-sectional studies, which are a single snapshot, then case control studies, and cohort studies. First of all, let's consider cross-sectional studies. Cross-sectional studies take a snapshot of a population at a single point in time. And that allows them to help identify associations between different variables. For example, as we can see here in the picture, some people have been exposed to a particular toxin, other people haven't been. We take a particular snapshot in time and we measure them all right here, right now. And that allows us to understand, perhaps, are there some associations between exposure and some of the traits that these people have. However, cross-sectional studies can definitely not be used to establish cause and effect relationships. The second type of analytical study is a case control study. And a case control study compares individuals with a particular disease or condition to individuals without it. We often call the people who have this phenomenon or condition or disease, etc., we call them the cases, and the people who don't have it, we call them the controls. And the goal of case control studies is to identify factors that might have contributed to the development of that disease. There are several steps that you take in case control studies, obviously before you start analyzing the data, which we don't discuss here. First of all, we have to identify cases. So we have to select individuals who have the condition or the disease that is of interest. The second thing we have to do is we have to identify the controls. So we have to select individuals who do not have the disease or condition, but who are similar to the cases in other characteristics. We often say that both the cases and the controls in case control studies should really be sampled from the same population. They should differ in no other way than that one group has the condition and the other group does not. Now, finally, obviously, we collect information or we collect data. We gather information about the exposure of interest for both the cases and controls. So let's take a look at for example, an example in sport and exercise. Imagine that our research question would be if there is an association between excessive training volume and the development of overuse injuries in young athletes. Then our cases would be athletes who've been diagnosed with overuse injuries, and our controls would be athletes sampled from the same population That means equally old, have had similar relationships with exercise, etc., but who have not experienced overuse injuries. We then would collect data, which would be to gather information about the athlete's training regimens, including how many hours per week they've been training, the intensity of their training, and all the types of exercises they've been doing. And then finally, as an analysis, we would calculate the odds of having an overuse injury if you belong to the cases group versus the control group. And a higher, what we call odds ratio, would then suggest that athletes with a higher training volume are more likely to develop overuse injuries. However, remember, we cannot infer causality from this design, and these studies are generally very prone to recall bias, where cases are more likely to recall their past exposures than controls. For example, if someone is often injured, we called them the cases, they might have a better recall of when and how they got injured. In other words, the exposure that perhaps led to that injury than if you are less injury prone. The last type of analytical observational study I wanted to discuss is a cohort study. And a cohort study is a type of observational study that follows a group of individuals called a cohort over time, and then assesses the development of disease or other outcomes. They're particularly useful for studying the incidence of diseases, injuries, outcomes, etc., and the long-term effect of particular exposures. So again, there's a few key steps in cohort studies. First of all, we have to identify the cohort that we want to study. So we have to select a group of individuals who are currently free of the disease or the exposure or the injury, etc., of interest. Then we collect baseline data. We gather information about the exposure of interest and other relevant factors that we think might be important in the study. And then the third step is we follow up that cohort over time and see who actually develops the condition, who develops an injury, who develops a particular disease throughout that follow-up time. If we take another example similar to the last one we used in sport and exercise, then we could consider the research question, is there an association between early specialization in a particular sport and the development of overuse injuries in young athletes? In that case, our cohort would be a group of athletes who've not yet experienced overuse injuries, and we were to collect baseline data about these athletes' sports participation, training volume, and other relevant factors when they enter into our study. Then we follow those athletes up over several years and assess the development of overuse injuries. Finally, to analyze the data, we would then calculate the incidence rate of overuse injuries and compare that between athletes who specialized early versus those who didn't. And as such, we can compare the relative risk of overuse injuries between these two groups. Causality can be inferred from cohort studies. However, they have as a huge disadvantage that they are time-consuming and labor-intensive, and there's often a significant loss to follow-up, which might mean that, for example, you don't have enough participants left at the end of your study to make any meaningful inferences.